Hi, this is János. This is the Real World Audio, and today I'm looking at the difference between transistor amplifiers and vacuum tube amplifiers. And I know this subject has been known down to the bone, but there are really fundamental issues about it. Why is the difference such? And I'm not going to look at listing you a couple of different manufacturers and doing comparisons, and you will be left with very little information whatsoever, because when you just buy a component, it's just a box and something is inside the box, and when we are just talking about brands, then it's just individual cases and it's telling you nothing. Nothing else than just some idolization of components. Ooh, this sounds good because this company really knows how to build it, and just let's deify it or put it on a pedestal. But you have to open it up and see, why is it like that? What makes the difference? And now I'm going to talk about the difference, what is under the hood, and what makes that big difference, and why do we experience like quite a few audiophiles who have vast experience with both topologies, that tubes have seemingly so much more potential in them than transistor based amplifiers. And now I'm not talking to the young titans who are listening to their 10th solid state amplifier and never heard good tube amps in their life, because if you do not have the experience, then of course you will have a preference for one technology. So I'm really talking about to the more mature audiophiles here, and those who are interested, who really have experienced a larger variety of gear, and wonder how come there is much higher potential for beautiful sound or natural sound or lifelike sound with vacuum tubes versus the seemingly powerful or superficially powerful but rough sound of the solid state gear. And Hugo has shared a wonderful comment on my last video, and I'm going to read it out because he summarized it really good, and he is saying his suspicions and his perspectives and gut feelings, and I think, Hugo, you have hit the bullseye with your feelings, because that's pretty much my experience as well. So let's read. Hi János, the subject of natural sounding music with tubes versus solid state has come up quite a few times. From a technical perspective, this is very fascinating. Question is, what makes it like that? Is this component driven or design driven? My gut feeling that it is predominantly but not exclusively design driven. And this is a gut feeling as well. Before we go on, I think that that's my perception as well, that the major difference between a tube amplifier sound and a solid state amplifier sound is due to the topology and the design choices that the manufacturers are making. For example, now let's look at tube amplifiers. When we build and design and build a tube amplifier like a solid state amplifier, it's going to sound like a solid state amplifier. What am I talking about? I'm talking about push-pull topology, class B design, and undersized power supply, so that we have, let's say, a power supply that is capable to deliver 100 watts for an output stage that puts out 100 watts. And for the power supply, it's not used. We are not using like brute force filtering, but using instead heavy regulation. And when you put regulation in the power supplies, regulation for the filaments, and we put in a lot of negative feedback and push-pull topology and pentodes and a couple more ends, you end up with a sound that is undistinguishable from a solid-state amplifier. And yes, I have heard in my life tube amps that sound so solid-state-like that they are like, ooh, now this is a really solid-state amp, and then you look at it and wow, these are tubes, what's going on? And yeah, that's what's going on, is that the design choices that were made in the topologies, namely the undersized power supply that causes the clipping and compression ahead of time, and push-pull topology with class B operation, so that there's a lot of crossover distortion appearing. The harmonic structure is also similar due to the push-pull design to the lower order harmonic cancellation harmonic structure is similar than that of a push-pull design, and even though the tube amps naturally do not have high order harmonic distortion, but that high levels of negative feedback loop to mess up the high frequencies almost as badly as you see the same thing happening in a solid-state amplifier. And of course now you will be saying that, oh, there are topologies with solid-state that have really extended feedback loops so that it does not impact until like the megahertz range, something like that. Yes, those are very few curios, and there's like a few lucky people who have heard like that, but that's not the vast majority of solid-state amplifiers. Those are the really rare exceptions. The vast majority that is present in 99.9999% of the homes really falls into that category, where the feedback loop really butchers the high frequencies when the amplifier is pushed. And that's why, how can you observe it? And now you're saying, no, János, I read the figures for my amplifier and the distortion figures are super low. Yes, when tested with a simple sine wave and when you are not pushing your amplifier. But when the amplifier is being pushed not by a simple sine wave, but a very complex music, let's say a Cranberries concert reproduction, and in this condition, when the power supply is heavily challenged and the signal transmission capability also very heavily challenged, now here when we are trying to push information through the extremes of the available bandwidth, then we can observe really amazing level of distortion happening on both the high frequency end of the spectrum and low end frequency of the spectrum. And that's why those figures that we read as THD figures, and they show these vanishingly low figures for solid-state amplifiers, don't mean anything, because they are representing an ideal situation, and also very, very important that this ideal situation is much more ideal than in real life, because these numbers are tested on non-inductive resistors. And if you dig deeper into the material, you will realize that there's a cat in the house. Kintaro, let me grab him. He ran away. Attempt failed. Anyway, next time he is going to come back. So, what was I? He is coming back. Nah, he wants to play. Okay, so I think he won't be coming back for a while. So what is happening is that the figures, the numbers that you read for solid-state amplifiers are given in an ideal situation that test them as their ability as a heater, not as a music reproduction device which drives the real loudspeaker, but as a device that heats up a piece of resistor. And role, they are absolutely perfect given a very simple signal, a simple sine wave, and that's it. Heater on a sine wave. And that's where the numbers are just off the charts. And that's why when people listen to them, it doesn't make sense, because that should be a perfect amplifier. And what we hear is that actually when you do not push it, so like there's a girl with a guitar, la la la, singing a very simple tune, simple melody, nothing is pushed to the limits, then it can come out pretty well actually, and nice and clean. But once you put on cranberries, then the whole thing falls apart. And that's the reason for that, that the measurements don't really live up to reality. And then you would say that, come those guys who like do like live concerts or just have like crown amplifiers and don't care about this audiophile BS amps, but like true real hardcore heavy muscle amplifiers that you can use with PA systems for the road. And yeah, with those you can bang on cranberries and they will come out loud and clear. But then you will find a lack of resolution. So what's going on there? Partially what's going on is that you have, with those big ass amplifiers, a power supply that is able to handle the push. And when we have our audiophile amplifiers, usually the power supplies are just extremely undersized. And when I continue reading Hugo's comment, then that's what he is mentioning. Whatever the size of a power supply, for a fraction of its cost, you can make an output stage that will match its peak power, which is a recipe for acoustic disaster. It takes a lot of restraint to design a 100-watt linear power supply for a 4-watt solid-state amplifier. And when you do that, that's when you will be surprised to hear that, wow, this thing actually sounds really good and it's listenable. And it doesn't sound like any typical solid-state amplifier, and it's much more musical, and it doesn't get as distorted when you are pushing the amplifier to its limits. Of course, with 4 watts, you are much more restricted with loudspeakers compared to a 100-watt or 400 watts amplifier. But when you made that 4-watt solid-state amp with a very efficient speaker, let's say like 100 dB plus sensitive loudspeaker, then you will realize that it's more than capable to handle quite sufficient volumes without being stressed. Of course, if you want like 100 dB plus levels, it cannot supply it. So if you are looking for that, don't look for a 4-watt amplifier. Just have some minimal common sense. That's my comment to those who want to comment like that, because I see these comments coming up like, Janos, I need 130 dB plus, one of my ears bleed and I'm not happy unless I'm getting that, and that 4-watt is just not cutting it for me. Yeah, if you want 130 dB, you should have equipment that does that, and don't even think about 4 watts. There's common sense for everyone. And I know we all have our priorities, what we want to hear, and sadly I noticed that this is such an Achilles heel for people in audio, that once you love something, then you assume that everyone else is an idiot, and especially on comment sections, luckily not my channel, but when I look at other channels and discussion forums, people are constantly crapping on each other. I just find that really awful. Like someone comments, I love to listen to music quietly, softly, late night, and then he gets comments like, oh, but dude, that's BS, you need to have at least like 130 dB, if you don't do that, you never heard music in your life before, and you don't know what your gear is capable of, and mine can do that, it's so much better than yours. I really have no really words for that attitude, and I really hope that you all cracked up of those comments and or maybe started crying, because that kind of attitude is really what ruins channels. And as you noticed, I don't have these types of comments on my channel and this type of attitude who are like people trying to sour your mood or my mood, because I just, I just don't tolerate this type of comments, and I call out people on their BS when they do that. And if there were, like, in the history of my channel, only 3, I would not say users, but abusers who abused the comment section, and then I just forwarded them to YouTube and let them handle it. Okay, I think this guy is trolling this channel, and then YouTube will take care of the person. I don't want to go into little battles like that. There's a much better authority on YouTube who can deal with that, and it's YouTube itself. But now, going back to amplification, what else did Hugo share with us? More often what we see is a 300 watt class D power amp driven by a 100 watt volt power supply. Yes, that is a big problem, especially now that we have the SMPS power supplies, the volts. They are just really choking down the amplifiers, but that's true also for DACs and any kind of unit that is fed by the volts. And that's why all the rage about those linear power supplies, the LPSUs, the low voltage supplies replacing the volt, because they are able to generate much better voltage, supply voltage and current to the device than that joke of a power supply. The volts, the output, the power that they put out is just a nightmare. And what I recommend is that you should not even have them in your house, let alone in your power supply, because even if you have like computers and LED lamps in your living room plugged into the same circuit as your stereo, the switch mode power supplies create a lot of switch mode noise, high frequency noise that goes into the line AC. It's fed back into the grid and it reaches your audio gear and causes a lot of extra strain and fatigue in the sound, and the sound is turning into a hollow version of itself. It's like the substance is disappearing and it becomes like a ghost. And then the manufacturer, as well as the YouTube reviewer, proudly declares that if you replace the volt with a brick power supply, usually of 36 or 48 volt, you can triple the power. Yeah, and it's kind of ridiculous, because you can't change the power with your power supply. You just change the amount of available reservoir for your power section, which is the same regardless of what kind of power supply you have. When you have a better power supply, then of course it can be fed better, you will have less clipping on it, but it will still develop the same amount of power, but at a much less clipping. But it will not be like your 50 watt amplifier will not turn into a 200 watt amplifier because you put a better LPSU on it. So that's kind of ridiculous. Unless there's some electronic regulation in the circuit board of the amplifier that down-regulates the output power if the power supply is inadequate. I can imagine that nowadays some manufacturers are doing that, but then I found that kind of like really like I don't understand why anyone would do something like that, other than just sprinkling pixie dust. It's kind of like, I call this attitude when companies try to pull BS like that on the customer. It's like blinding the peasants. That's the expression for that, is that when they are just doing so obvious crap on you and calling that as a added feature. So like, oh no, this is an added feature if you put a better power supply, more power. No, it's kind of like, guys, this is BS. It should be designed with the appropriate power supply. If not, if there's just such a big discrepancy in it that the company cannot resolve the balance between power supply and power section, then that design is flawed at its core and you should avoid it, because that manufacturer is not honest to you. So I think about that. As I said, my gut feeling tells me that you can make a natural sounding solid state amp, and I agree. It is possible, and Michael Yee has done that, and there is I see the same thing, that what he has done is just gone to town with the power supply. So it's a 2 times 50 watt per channel class A amplifier with 6 dedicated power supplies, and he has big EI core transformers in it. Now no toroids. Toroids is one more reason why the solid state amps sound like the way they tend to do, is that the use of toroid transformers is because you can get the same VA rating for a much smaller size transformer. And so it's cost saving. So what they are telling you is that, oh, we are giving you something which is better. No, they are cutting costs and they are selling to you as if it was a good thing. It's kind of like taking, like docking 2/3 of your payment, and they are giving you 1/3 of the money. Oh, this is much better for you because it doesn't weigh down your wallet so much. That's the exact same thing that's going on with toroid transformers. And they say, oh, they have the benefit that they do not radiate EMI fields as much. Yeah, that's true. But also what they're not saying is that if there's any DC on the line AC, they immediately oversaturate and they become absolutely worthless to transmit any kind of power at all. And that's why I hear just so many solid state amplifiers that have like 1000 VA or higher VA rated toroids, and they sound as if they were like a 1 watt rated amplifier, and you can't push them beyond just the minimal SPL, and then I can hear that it's clipping, it starts fatiguing already. And that's because the toroids are saturated. And then those of you who say, no, I never experienced that, then please just have your line AC checked out, and you will realize that you live in an environment where there is no DC present in your line. And if you live in rural areas or you don't have many neighbors, then that's very much likely the situation. So if you live in an isolated community where the power lines are not stressed at all, toroids are perfect for that. However, if you live, like, let's say here, let's say in Honolulu or Waipio, then you are fudged, royally fudged, because it's just like toroids crap out here. It's just not a good thing. I can hear every day. I have an isolation transformer with 3 toroids feeding 3 separate circuits, and I have it in the living room, and I can hear them hum every single day. And when you hear the toroids humming, that's the sign that there is DC present in the line AC, and it's oversaturating the toroids. So why did I say all of these yada 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 things? It's because if you want the soup, the recipe to design a solid state amplifier that has a natural sound, then you need to follow these very simple rules. Number 1, avoid toroids for power transformers, not because they are bad, but because if they happen to oversaturate, they totally disrupt the natural characteristic of the solid state amplifier. Yes, it's true for tube amps as well, but solid state, the transistors are much more susceptible to this kind of disruption than vacuum tubes are, and they will hurt more when this happens, when it happens with vacuum tubes. With vacuum tubes, you simply notice that the power goes out from the sound, but otherwise they are okay. But when it happens to solid state gear, it just becomes even more unlistenable than it was. The power loss is not as noticeable as with vacuum tubes with toroid core saturation, but the fatigue just jumps up, and it becomes very very bad for those who have good high frequency hearing. Becomes unlistenable. That's one thing. So no toroids, oversize your transformers, and also I would say oversize your power needs. So if you want to have a listening experience, let's say you are matching it with your loudspeaker, and I say you need like 20 watts of power for undistorted listening. That means that you are listening at pretty loud levels. Then I would say you need at least 20 times as much power capability to be designed in your solid state amplifier to remain natural sounding at its peak power. And that's because solid state gear are extremely sensitive to clipping when you are pushing them towards close to their limits. And you can push them really close to the limits because a lot of music has very high energy transients. And when you're looking at the limits, you need to look at where the transients are. And you can have a music material with a 1 watt average power output, and it can have like 300 watt transients on it. And you must design your solid state gear that the transients are still within the peak handling ability of the solid state amplifier. So with solid states, you must never get anywhere close to saturating the power requirement. Do not ever max out the power requirement. So look at what you would need: transients, X watts, and triple that power, and that will be your safe zone to rest with the solid state amplifier, to still have it stay in the natural zone. Next advice is to keep like the power supply as linear and as brute as in a vacuum tube. Use as little and as plain regulation as possible. If you can get by with a choke filtering, try it. It will take a lot of trial, and it will. If you try to put chokes in a solid state design, then you will realize that you have very long ago left the commercial road, and you will need chokes which are the size that and the cost that will make the design absolutely prohibitive. And so you will be left with a totally enormous, gigantic amplifier, and at an extreme cost, just an extreme parts cost. That's one thing. Also, try to keep it class A. Try to have as low number of stages as possible, as high quality transistors as possible. What else? Try to feed every stage with a separate power supply. Now we have turned our project into a true giant of an amplifier. And pay very close attention to RFI EMI shielding of all the capacitors, because that's what I noticed, is that solid state, the transistors are beyond sensitive to EMI, RFI, and if I shield the capacitors with the copper tape and then ground the copper tape, the change in the unit, that it goes from that typically solid state sound towards a natural sound, the jump is enormous. So for everyone, you can, so until now, what I listed is design criteria. So you want to design natural sounding solid state gear from ground up. If you follow that, basically you build them as if you would go on about building a tube amplifier, then you will reach maximum naturalness. But it will be at a cost that with such a direct layout, direct topology, you will be revealing extremely the sound of transistors, and that's why your transistor selection becomes absolutely critical, absolutely vital, and you will spend a lot of time sorting through transistors, finding the units that you need. And I think there's the Serbian amplifier maker Taran, and that's what I have not heard his amplifiers, but I have heard that he is the core of his success is that he goes through thousands and thousands of transistors and measures them, and then takes great pains to manually select and match the transistors. And that's why his gear sounds good, because the basis of audio to achieve a quality equipment, it depends on the parts. And a lot of the solid state amplifier development was about how to make the topology more and more complicated to accommodate for junkier and junkier transistors, how to hide the visibility of these units, how to grind them with feedback, how to normalize them with feedback. That's why when you look at solid state designs, there's like a myriads of feedback loops, and that's to bring the transistors in line. And when you match the transistors, then you don't need as many feedback loops, because you don't have to normalize the differences, because they are equal. And there's the misconception that the tube amplifiers have a lot of distortion and solid states have a little distortion, because solid states are more linear. I mean, the transistors are more linear than vacuum tubes. That's an absolute erroneous idea. Vacuum tubes are much, much more precise, much better amplification devices than transistors. However, the excessive amount of feedback in transistors make them appear as if they were really linear. And when we apply the same amount of feedback on vacuum tube gears, they will be even more linear, even less THD than a comparable solid state amplifier. However, they don't require that to operate, and that's why, luckily, I just really stopped that thought, because unfortunately most manufacturers really push their vacuum tube designs to have as much feedback as possible, to make them sound as much as solid state amplifier sounds, because that is the peer pressure. That's what the manufacturers think, that the consumer wants that, but for sure that's what the reviewers want to hear, because they are comparing it to solid state amplifiers, which an approximately similar power output solid state amplifier costs a fraction of the cost of making a similar output vacuum tube amplifier. So the tube manufacturers have to really compete against a totally unfair disadvantage, a handicap, that at the same price point they really have to just put in a lot of cheese to make that tube amp compete with the much cheaper solid state amplifier. driving the same inefficient loudspeaker which tubes normally have no business driving at all. But nowadays that's what most of the loudspeaker companies are doing. They are just dropping the efficiency, dropping the sensitivity on their speakers, so we need more power to drive them. And that's why the lot of vacuum tube manufacturers are just turning into high power. And today, like a 20-watt tube amplifier is considered low power, which is, I think, it's kind of like the world gone upside down. Like 20 years ago, 20-watt class A, single-ended triode was a whole lot of power. And today, well, it's nothing. And it's sadly, that just shows that it's not nothing. It's still a lot. That's quite a lot. It's just now the loudspeakers just declined so much in sensitivity, in efficiency, that today these gizmos, they need a lot of juice to drive them. And if we want to stay in commercial amp field, then we need those high power gizmos. And that's hugely compromised. And I think when we look at those kind of vacuum tube amplifiers, there's a whole lot of compromise in them. There are some better examples where the manufacturers make kind of the most out of it to still sound like semi-decent, despite being crippled, to make them be able to drive, like a 2-ohm speakers and stuff like that, with like a 500-watt output or something ridiculous. But if they put the same amount of effort to make them able to drive a loudspeaker that matches a tube amp, then you would have a phenomenal amplifier on your hands. So I think, Hugo, I totally agree with you, is that today there's like the modern hype choices that the manufacturers are making are pushing the solid state industry or choices towards the corner where they are in. And now, like, generations have grown up listening to solid state sound, so I think now is just the de facto normal for everyone. No one's really complaining of it, except those weirdos like me who did not grow up listening to solid state gear as their idols. I grew up listening to live music, live singing. Went a lot to symphony, to opera, to live concerts of every kind, mostly unamplified. I really hated, when I was young, any kind of amplified concert with PA system. I thought the whole lot of them just sounded absolutely abysmally dreadful. And luckily I haven't heard an audiophile system until I was 20 years old, so I was not tainted by having my development skewed by any of these factors. Or because that's what we don't notice, that what we get used to as audio gear and what we accept as high-end, it really creates a baseline for us, and we reference everything to that. And I think my advice is that try not to use that as reference. Try to use unamplified sound, unamplified music as a reference, and at least for natural sound. And other than that, my ultimate advice is really just listen to whatever music you like, with whatever amplification you like. If you like the sound of your favorite solid state amplifier, then that's absolutely right. You don't need to change. It's just for you to know that there are lots of different things out there. And it's just a very narrow attitude when someone thinks that, oh, okay, just like I have something, I like it, everyone else is an idiot. And then really your whole universe shrinks, and you will have your options really limited. And as the time passes, decades go by, or listening preferences change, and that's why it's important to have our attitude be open to a wide array of experiences, because when it's time for you that your desire, what you want to listen to, how you want to listen to changes, then you have a direction where you can go, and you know what, okay, now it's time for me to look for something else. And but until then, just enjoy the audio system that you have now, and my number one advice is just try to focus on the music, on what you listen, and just listen what you love. And if you can't listen to the music that you love, then you have a problem. That's when you need to change something in your system. Because if, for example, you love like a couple different groups, and you can't listen to them because your system is so refined that it doesn't play that anymore, then you're in a pickle. Just admit it, you're in a pickle. You've been sidelined to a dead end, and you need to get yourself out of the dead end before you are completely lost. And yeah, I think now this was a little bit winding too much, but I think that's about the topology aspect of vacuum tube versus solid state, is that topology is 90% of the choices, and when we think about the topology, the power supply requirement for vacuum tubes makes them much more amenable to good topology choices, because we need very high voltage with low current to supply the power tubes, and that makes the choke filtering much more feasible, amenable, and possible. For solid state amplifiers, we need low voltage, high current, and for that you need a really low DCR, very high current choke. And number one, you cannot even buy those on the market. You need to have one specially made for you, which will just totally explode the cost of of the parts for you. So I think that's about it. And what about the rest, 10%? I think that's a point for another video, that the inherent difference between transistors and vacuum tubes, because I found that there are really major differences. So even if we equalize the design criteria, then still there is a very big edge for vacuum tubes that I have not talked about yet. And it is something that will reach many as a big surprise, but it will be an explanation for some of you, and cause for a major aha moment. But we'll leave aha for next time. And have an awesome day. And unfortunately the cats haven't made their appearances. I see Kintaro going to the kitchen. He really has his mind on the food. Machi is just sleeping on the floor, so no cat activity. So as Hugo said, that this is his last word, last sentence. P.S. The cats contribute to your channel. And sadly, no, this video they didn't contribute anything. They are really slacking. But I see Machi is really sleepy, so she's excused. So thank you, Hugo, for your fantastic comment, and thank you for chugging along and listening to this very long-winded video. Have a wonderful day. Bye bye.